Hello and welcome to Module 1 in our new series SDL2 with C++. We're going to begin today's session with a brief introduction to the library, and then we look at some of the functions in this library that we will be using during our project. To begin with, the full form of SDL is Simple Direct Media Layer, and the term layer that you see there in its name is because this is an extension library. Now, this library allows us access to devices like the keyboard, mouse, joystick, etc. And from those devices, you may have already figured out that this library is associated with game creation. And while you're right, the keywords to note here are low-level access, meaning that this library provides us with a framework to access operating system functions that, of course, games need in order to run. Now, this library is written in C, but also works with C++. It is a cross-platform library and so can also be used with Python, C#, Rust as well. Let's now take a look at the subsystems of this library that come together to make our games possible. At this point, may I ask that you like this video and subscribe to the channel. It means a lot to me and gives me the motivation to produce more content like this. Thank you. And SDL2 provides us with an audio subsystem, a video subsystem, CD-ROM as well. We have a file I/O subsystem, joystick handling, threading as well, and then we have timers and event handling. Of all these subsystems, it is a file I/O subsystem, threading subsystem, and the event handling subsystem that are automatically initialized when we call SDLInit, which, as you see there, must be called before using any of the subsystems of this library. So let's now take a look at SDLInit in a little more detail. As we just saw, SDLInit automatically initializes three subsystems, namely file I/O, event handling, and threading. Any additional subsystem that needs to be initialized must be passed in as a parameter to this function. Now, you may pass in more than one additional subsystem to SDLInit simply by using the pipe symbol. SDLInit has a complementary function, and that function is SDLQuit. So whereas SDLInit initializes or starts up subsystems of this library, SDLQuit serves to shut them down, thus freeing resources for other applications to use, and we should call SDLQuit before exiting our program. Now remember, SDLInit is a function, and so it has a return value. On success, it will return a 0, and a -1 if it fails. We need to check for this, of course, in our code. Now, instead of passing in the additional subsystems as parameters to this function, we could initialize all subsystems just by sending in one parameter to SDLInit. And that parameter is SDLInit everything. Let's now move on to the software requirements for the series. We will use Visual Studio 2022 as our development environment, and of course we need the library. Links to both of these you will find in the description of this video. So if you click on the link for Visual Studio 2022, you'll be taken to the downloads page where you can proceed to download the community version. For the library, click on the link in the description, and that will take you to the libsdl.org page, where you can click at the top here or on SDL releases. Both of these will take you to a GitHub page. Scroll down the page and download the vc.zip folder. Extract the files to a folder on your disk that is easy for you to access. We will need that folder for our project. Let's now talk about another function, SDL Create Window. Now, by its very name, you know that this function is going to create a window. We need to provide the title for the window, the position of this window on our screens, the dimensions of the window, and flags, which are of course optional. But what's the purpose of this window? Well, this window is the one within which our game will run. So let's look at the arguments now. We need to provide the position of the window. So that would be the X position and the Y position. These relate to the X and Y coordinates of the top left-hand corner of the window. We could use predefined positions SDL window pause center to give us a centered window, and SDL window pause undefined, which means we're not really concerned as to where on our screens the window is created. The next arguments are the dimensions, so we provide the width of the window and the height of the window. Flags are optional, as I said, so we could have 0 or more flags. Examples of flags are SDL window full screen to give us a full screen window, SDL window shown for a visible window, and SDL window hidden for an invisible window. Again, SDL Create Window is a function. The return value is the window if it is successful, otherwise a null on failure, and we can check for this in our code. Right? Now moving on to the next function, SDL Get Error. This is the error reporting function of the library, and of course it's going to return a string. Now this string contains what? It is the last error that occurred. Now since this function only reports on the last error that occurred, it's important that we call SDL Get Error after every function that we need to check success or failure of. Right? Now if the string is an empty string, of course that denotes that there is no error. Moving on, you can see there the asterisk indicating that this is not a function, but rather there is a pointer involved here. And yes, this is a pointer to a structure that is used to handle rendering. Now, if you're not familiar with the term rendering, what that means is essentially the drawing of a scene or a frame in your game. Now, this structure requires SDL window. But what is SDL window? We just spoke about the function SDL Create Window. We know that this function returns a window. Internally, what it's returning is a pointer to a structure of SDL window type. Right? Now, this particular structure, that is SDLRenderer, is required by many functions in this library, and therefore before accessing these functions, we need to have created this SDLRenderer structure. But how is it created? And that brings us to the next function, which is SDLCreateRenderer. Now this function creates a rendering context for a window. If you find those terms rendering context confusing, I'm sure it will be clear by the end of this slide. So let's look at the arguments now. We have a variable window, which is essentially a pointer to a structure of SDL window type. Then we have an integer type index. Now this relates to the driver to be initialized. We normally leave this at -1 to use the or initialize the first available driver. Unsigned in 32 flags, examples of this could be SDLRenderer accelerated, which means that our game or our program is using hardware acceleration. And if you're wondering what hardware acceleration means, well, essentially it means that our program is going to be using specialized hardware to perform certain tasks. So in a game, for example, graphical operations would be handled by the GPU, leaving the CPU free then to handle other tasks, thus improving the performance of the game. Now, SDLCreateRenderer will return a valid rendering context on success or a null if it fails. And again, you see those terms, rendering context, right? So this essentially is nothing but the structure we just spoke about, the SDLRenderer type structure. Once this structure is created, we can then proceed to use it in a function like SDLSetRenderDrawColor, which is going to set the color for our window. Now, of course, there are arguments. The arguments will be the rendering context, which we know now is the SDLRenderer type structure. We also need to provide the red, green, blue values for the colors or the color we want for our window. Now, how do we get these RGB values? If you're not sure about the red, green, blue values of the color you want, the easiest way to get them is to go to Paint, select your custom color, and then Paint gives you the RGB values, which you could then include in your code. We also need to provide an alpha value, which is a transparency value. And if you're not familiar with the term transparency, if you look to the right of your screen, these are what are called opaque colors. You can see they're really vibrant. whereas these are less opaque or more transparent. So we need to provide that value. We normally stick with opaque, which is the numerical 255, or you could also use the predefined SDL alpha opaque, which would mean the same thing. Now for the next function, SDLRenderClear. So whereas SDL set render draw color set the color for our window, SDLRenderClear is what will actually paint the window in the color we selected, right? Now, of course, there are parameters to this function, and the parameter it needs is nothing but the rendering context, which we know now is the structure of SDLRenderer type. SDLRenderClear will return 0 when it's successful or a negative error on failure. Let's now talk about the next function, SDLRenderPresent. We've seen how to set the color. We've seen how to color the window, right? SDLRenderPresent will actually update the user screen with any rendering or any drawing performed since the last call to the same function, right? Now, of course, RenderPresent requires a parameter, and that is, of course, again, the structure of SDLRenderer type. One important point to remember is that all rendering functions operate on a back buffer. But what does that mean? Let's look at a visual to understand this more clearly. So when you watch a play, the scene is being built behind the curtain, and it's only when the curtain is opened can you view that scene, right? So similarly here, the scene is being created in another place in memory, referred to as a back buffer, and it will not be visible on the user's screen until and unless SDLRenderPresent is called. So I hope that's clear. The next function, SDLQuit, and as we saw earlier, this function is a complementary function to SDLInit. Again, it shuts down all SDL subsystems and frees the resources, right? This function, as I mentioned earlier, must be called before we exit our program. Now, before we go, let's look at some code to recap what we've done so far. I recommend you do not type in anything simply because when we're using SDL, we need to set up the project to use the library, right? So we will be doing that in a later session. For now, just follow what's going on screen. First statement, including the header file SDL.h and then IO stream for using input output. Remember, we're using C++. We have a main function there. With our main arguments, we're going to declare and set certain variables. We need a window variable to create our window for the game to run within. This particular variable will be used by SDL Create Window, as we will see shortly. The next variable is renderer. Again, this is going to create our rendering context. We then initialize the subsystems, calling SDLInit and passing in the parameter SDLInit everything to initialize all subsystems. We're checking for success or failure of SDLInit. If it fails, then of course we print out a message on the console calling SDL Get Error as well, and then exiting the program, right? In the next line, if SDLInit is successful, we then use that variable window calling SDL Create Window, and we are providing the title, the X position and Y position of the window, width and height, and then the optional flag. If we have a null returned by SDL Create Window, then of course we exit the program after displaying the error and calling SDL Get Error. We call SDL CreateRenderer to create the rendering context or our SDLRenderer type structure, right? Of course, we need to pass in the arguments, which is again that pointer to the SDL type or SDL window type structure, I should say, right? And then the index and the optional flag. Here we are indicating that we are using hardware acceleration. If a null is returned, we then proceed to display a message and call SDL Get Error, after which we exit the program. Now we call set render draw color, passing in the SDL renderer type structure or the rendering context, and then the RGB values for the color we want, as also the transparency value, which is the alpha value. Calling render clear then to paint the window in the color specified, and then render present to update our screen, right, with the rendering done. We then call SDL delay, which is nothing but a wait command. So this window will remain on screen for 3000 milliseconds or 3 seconds, after which we call SDL destroy window. Remember, we need to free resources. So we are freeing the memory that was occupied by SDL window or the window, and SDL destroy renderer to clear up the memory occupied by the rendering context. And we call SDL quit to shut down all subsystems. That's all. So let's run this now. And there we have our window, which remains on screen for 3 seconds, right, before exiting. What would happen if, before we called render clear, we call render present itself? What do you think would happen? So let's run this and see. Now, if you thought we would get a black window like this, you are right. Essentially, what's happening is we are not painting the window. Render clear, remember, will color the window in the selected color. But since we're calling it after render present, we're essentially updating the user screen before coloring the window. Right, so I hope that's clear. This ends our session for today. Till the next session, take care. Bye.